All right, let's talk about algebra. But forget dusty old textbooks for a second. I want you to think of it as a code. A secret language, really. It's hidden in plain sight, and it powers, well, pretty much everything. And guess what? By the end of this, you're going to be a code breaker.
So let's just get right to it. The number one question, the one we've all asked, staring at our homework, why are there letters in my math class now? You know, it feels like it's designed to be confusing, right? But I promise you, it's actually the key that unlocks the whole thing.
So yeah, instead of math, let's call it what it is, a secret language. It's a system designed for one thing, really, solving mysteries. And those letters, they're not there to scare you, they're just placeholders. Kind of like a sticky note that says, mystery clue goes here. We just haven't found it yet.
Okay, so if we're going to be code breakers, we need a toolkit, right? Every great detective has one. So let's go over the essential gear. This is the stuff you'll need for any algebraic mystery.
First thing in our kit, the variable. You've seen it. It's usually an X or a Y. This little letter is the absolute heart of the puzzle. It's the who in a whodunit. It's the unknown number we're hunting for. You could even say it's the main character of our whole story.
Now, a detective is nothing without clues, and that's where constants come in. These are just the regular numbers, like 3 or 10 or -5. They're the solid, unchangeable facts of the case. They're the footprints, the alibi, the stuff that's not a mystery and helps us figure out what is.
Okay, so what happens when you take our main character, the variable, and mix it with some of those solid clues, the constants? You get an expression, something like 4x minus 3. Now notice there's no equal sign. This isn't the whole puzzle yet. It's more like a sentence fragment, like a witness statement that gives us a juicy detail but doesn't solve the case.
And that brings us to the main event, the equation. This is it, the whole puzzle. An equation is when you take a fragment, like 2x plus 3, and you put that all-important equal sign next to it, and then put something else on the other side, like 7. That equal sign is the game changer. It says, hey, this side is perfectly balanced with that side. And boom, we have a complete mystery on our hands.
So, we've got our toolkit, but we can't just run in and start messing with things. There are rules. Every game has them, every world has them, and algebra is no different. If we want to crack the code, we have to know the rules. Rule number 1 is all about sequence. You've probably heard of it, BODMAS. It tells you the exact order you have to do things. Brackets, then orders like powers, then division and multiplication, and finally addition and subtraction. You can't just do it in any order you want. This is the law.
And now for the big one, the golden rule, the most important rule in all of algebra. Seriously, I want you to picture an old-school balancing scale. An equation is exactly like that. It's perfectly balanced. So what you do to one side, you have to do to the other. You add 5 pounds to the left, you better add 5 pounds to the right, or the whole thing tips over. This rule is everything. It's non-negotiable.
Okay, toolkit, check. Rules, check. It's mission time. Let's put this all together and actually do it. We're going to take everything we just learned and put it into action. Let's solve for x.
Here we go. This is our case file. 2x plus 5 equals 13. Our one and only job is to figure out what that x is. What number is it hiding? The scale is balanced. The clues are right there. The investigation starts now.
Okay, first step. Look at the side with the x. Our goal is to get that 2x part all by itself. Right now, that plus 5 is hanging around, kind of cluttering things up. So how do we get rid of a plus 5? We do the opposite. We subtract 5. But remember the golden rule? If we subtract 5 from the left side, we have to subtract 5 from the right side too. Keep that scale balanced.
And look what happens when we do that. On the left side, the plus 5 and minus 5 cancel each other out. Gone. On the right side, 13 minus 5 is just 8. So now our whole puzzle has simplified down to 2x equals 8. See? Way cleaner. We are so close now.
All right, this is the final move. X is almost alone, but it's still attached to that 2. And 2x just means 2 times x. So to get rid of that times 2, what do? The opposite. We divide by 2. And say it with me, what you do to one side, you do to the other. So we divide both sides by 2.
And what is 8 divided by 2? It's
4. And there it is. Mystery solved, code cracked. We followed the rules, we used our tools, and we found our unknown value. X is 4. Done.
But wait, don't think that's all algebra is. Solving for x is just the first level. What's really cool is that algebra isn't just about numbers, it's also about pictures. This is where it gets really visual, and the code, you could say, really comes to life.
So, you've probably seen this famous equation, y equals mx plus c. It looks a little intimidating with all those letters, right? But it's not a problem to be solved. It's a set of instructions. It's literally a recipe for drawing a perfect, straight line on a graph. Every single letter in there tells the line exactly what to do.
Let's break down that code. The x and y are just your coordinates, your horizontal and vertical positions on the map. But the m and the c, that's the secret sauce. M is the slope. That tells you how steep the line is. Is it a gentle hill or a steep cliff? And c is the y-intercept. That's just a fancy way of saying, where does the line start on that up and down axis? It's a whole roadmap, all packed into one tiny equation.
So you see, in the end, algebra isn't really about finding x in a puzzle. It's about something much bigger. It's a language. It's the language we use to describe the relationships between things. You know, the relationship between how fast you drive and how far you go. Or the relationship between the price of a new phone and how many people want to buy it. It's kind of like the blueprint for how the world works.
So, now you have the code. You know the language, you've got the tools, you understand the rules. It's all yours now. So I'll just leave you with this question. What mystery are you going to solve? Thanks for joining me on this explainer.